Hello. So for this problem here, I am going to use loop analysis to find all of the currents in this circuit. And if I know all of the currents in this circuit, it will be very easy for me to know all of the voltages at all of the nodes as well. So let's get started. I'm going to move this over a little bit. Okay. So the first thing I do is I mark all of my currents. Notice that they are all going clockwise. That is my default strategy. I always say that the currents are going clockwise. And I'm going to mark this one I1, I2, and this one is I3. All right, so I've got all my currents. They're all going clockwise. So the next thing I need to do is I need to mark all of my polarities according to each current. So anywhere where a current is entering a resistor, I put a plus. Anywhere where it is leaving a resistor, I put a minus. And I need to do this for every loop. So plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. There we go. So we've now got all of our polarities marked. Well, now I'm going to need to write an equation for each one of these loops. So let's start with loop I1. So I'm going to start down here in the lower left-hand corner, and I'm going to move around each loop clockwise. So if I pass through a resistor and it goes plus to minus, that's a decrease. If I pass through a resistor and it goes minus to plus, that is an increase. Same goes for a voltage source. So if I pass through this voltage source this way, it's minus to plus, so that is plus 7 volts. If I pass through this one this way, right here, it's plus to minus, and so that is minus 25 volts. Let's get started in loop I1. Okay, so it's going to be minus 110 I1. And we'll do this one. Minus 220 times the loop that I'm in minus the loop I'm sharing with. Minus 1K times the loop that I am in minus the loop that I am sharing with. And then finally minus 9 volts. And that all equals 0. Remember, we're just basically writing an equation showing all of the voltages around each loop. All of the voltages, according to Kirchhoff's voltage law, should sum to 0 around every loop. So here's my first equation. I need to put this in standard form. So first thing I'm going to do here is I'm going to take this 9 volts and I'm going to pull it over to the right-hand side. So there it is. Let's count up how many I1s I've got. So I've got 110 I1, or negative 110 I1. And then I've got negative 220 I1 and negative 1K I1. So we got minus 1,000, minus 1220, minus 1320, minus 1330 I1. So minus 1330 I1. Okay. Let's see how many I2s I've got. I see 1K I2. And finally, I am seeing 220 I3. All right, let's put a box around this because this is our first equation. Now let's do the second loop. I2. So I'm going to start right here, lower left-hand corner. So I'm seeing minus 1K, the loop that I'm in, minus the loop I'm sharing with. Minus 820, the loop that I'm in, minus the loop I'm sharing with. minus 100 times I2, because that's not sharing with anything. And that is one spin around the loop. So let's put this equation into standard form. So I'm seeing 1k I1. How many I2s do we see? I see minus 920. So minus 1920 I2. And then I see plus 820 I3. That equals 0. There is my second equation in standard form. And then finally, we've got I3 here. I'm going to start in the lower left corner again. So I've got minus 25, that's this, minus 560 I3, plus 7, minus 820, the loop that I'm in, minus the loop I'm sharing with, minus 220 times the loop that I'm in, minus the loop I'm sharing with. That all equals 0. So it looks like we've got, what do we have here? We got minus 18 on this side, so let's kind of move over to the right as plus 18. So that takes care of this term and this term. Okay, let's count up our I1s. I'm seeing 220 I1. All right, and for I2s, I am seeing 820 I2. And for I3s, what do I see? I'm going to use the calculator for this because I don't feel like doing it in my head. So we got 560 plus 820 plus 220. That is 1600. So minus 1600 I3. And there is our equation right there. All right. So we've got our three equations. They are in standard form. Let's go over to our system solver. This is a 3x3 system, 3 equations, 3 unknowns. So let's put in our coefficients. So minus 1330, it's that one. 1k, 220, 9, 1k, minus 1920, 820, 0, 220, 820, minus 1600, 18. Let's see what we get. Okay, so this is what my result is telling me. It's saying I1 equals minus 38.63 milliamps. I2 is 34.81, so minus 34.81 milliamps. And I3 is minus 34.4 milliamps. So what do these minus signs mean? Well, they mean that the currents are all actually going in the opposite direction of what I said. So I'm going to cross this out, and I am going to correct them. So sorry, it's a little ugly. It's okay. All right. So we now know what the currents are around each loop. Let's talk about how to find a current through a specific resistor. So I want to know, say, what's the current through this 1K resistor there? Well, let's look. So due to I1, we've got 38.63 milliamps going up through it. So we've got 38.63 going up. And then we've got 34.81 going down. All right, so let's see what the actual current is. It looks like the current is going to be going up because the current going up through the 1K is larger than the current going down through it. Let's see what the magnitude of the current going up is going to be. So we got 0.03864 minus 0.03481. So it looks like we've got 3.83 milliamps going up right there. All right, let's do it for another resistor. Just make sure that we've got the hang of this. Let's do it for the 820. So for the 820, I see that I2 is moving from right to left through it, 34.81 milliamps. So 34.81 going right to left. And then we've got I3 moving from left to right, so that's 34.4. So plus 34.4, and that is moving this way. So it's going to be moving from right to left, and it looks like we've got 410 microamps. So the current through this is 410 microamps moving from right to left. And let's look at the current going through, say, R4. Well, the current through R4, it looks like only I2 is going through R4. And so the current is going to be 34.81 milliamps going up. Now, if I want to figure out the currents through any of this stuff, all I have to do is repeat this process for any one of these resistors. And if I want to find the voltages, all I have to do is just do Ohm's law across each one of these resistors, and I can figure out what the voltage is anywhere in the circuit. So let's do something to check our work and make sure that we're correct here. I am going to look at this node right here. So we know we've got 3.83 entering, and we got 410 entering. So that means this current here must be leaving. According to KCL, you can't have all the currents entering a node, and you can't have them all leaving a node. So let's see what the current is through the 220. So it looks like we've got from left to right, we've got 34.4 milliamps. So we got 34.4 milliamps going this way plus 38.63 going this way. So it looks like it is going to be going right to left. And let's see what the magnitude of that is. So 3863 minus 0.034 4 equals 4.23 milliamps. So 4.23 milliamps, and I have been doing some rounding here, so I don't expect this to total up to exactly 0, but it should be pretty close to 0. So let's do it. So we got 3.83 milliamps entering, so 0.00383 entering, plus 410 microamps entering, so plus 0.41 entering, minus 4.23, 0.00423, and I'm seeing that we've got a tiny bit left over, which is 10 microamps, which essentially is a rounding error. So we're correct here. Like, this basically totals up to 0 right there. Everything is looking good. So we have solved this problem correctly. Okay, that is it.